Yes, my name is Hendrik Schreiber. I'm a PhD student at International Audio Labs in Erlangen, and I also run this little one-man show called Talktom Industries, which is that logo up there. It's just another baseline that I'm talking about, and the idea was to just rely on Mel-Features. If you're not familiar, are you all familiar with Mel-Features? Anybody not familiar with Mel-Features? Okay, there are a couple. I'm going to quickly talk about that. Usually when you do a Fourier transform on the audio signal, you get a linearly spaced frequency spectrum. Now our hearing is not linearly spaced, but logarithmically spaced. And the Mel scale is just another scale that is more like a logarithmic scale that is more similar to how we actually perceive things, how we hear. So it's a perceptual scale, and it is associated with timbre, like how musical instruments sound. And that again is connected with instrumentation, of course. So Mel-Features in one form or another have been used for genre recognition in the literature a lot. And that has been fairly successful. If you just use Mel-Features, you're gonna ignore temporal features like beats and all that. But most of that is actually not present in the AcousticBrainz feature set anyway, except for what Dimitri just mentioned, abstract like tempo summarizations, and there are some beat things in there, but it's anyhow, it's not very detailed. So for the baseline, the idea was to just use the low-level Mel-Features, and what you have is 40 features, and this is the first derivative of the mean as an example, but there's also max, min, whatever. 9 different variants of that. So we have 40 bands with 9 different global statistics, and that makes 360 input features. So what can we do with that? So the nice thing is Mel-Features, it's a frequency spectrum, so they have a spatial relationship, at least along one axis, the one-dimensional one, so adjacent frequency bins. That means we can use a CNN. It actually makes sense to use a CNN and not so much a DNN. Now we have 9 different ways of having those frequency statistics presented, min, max, and so on, the thing I just mentioned. And I figured best way to do it is just to model those as channels, and then just 40 bands. So we have 40 times 9 in channels. And the network that I've been used is pretty standard. It's just a convolution, dropout, pooling, norm, convolution, dropout, pooling, norm, and so on. 4 times, and in the end we do not a dance layer, but we do a fully convolutional network through global average pooling and then a sigmoid as output. So really nothing too fancy. Prediction, we also, I did also the F-score maximization to get to those thresholds to decide whether something like a genre is present or not, just like Dimitri explained. And subtask 1 versus subtask 2. Because it's just a baseline, I figured, just do some normalization and you just assume that children's is the same as children's with an apostrophe. And at prediction time, just revert that normalization and be done with it. So I kept that very simple. And the results, as Julian already mentioned, is very similar to the second ranked submission. So in the first task, this approach with the limited feature set does actually very much better than the fully connected network approach that we've seen. For the second task, though, we're doing a little worse. So whatever we could have learned from merging all those data sets together, we didn't learn in this approach. But the upside, it kind of shows that if you actually know what those features mean, because we have like 2,700 features in AcousticBrainz, and most people coming to the task, at least that's last year's experience, they didn't know how to interpret these features. So we have Mel bands, we have ERB bands, we have a Bach scale band, and so on. That's actually pretty much the same. So you can drop most of that, just ditch it, and stick with something that actually is discriminative and not just repetition or like something redundant that you've already done. So Fewer features do work, and if I was going to make this approach a little better, I'd probably add something in the temporal domain, just the beats, the onset, something like that, because there is, that's also been shown in the literature, there is a strong connection between genre and tempo. For example, a Viennese waltz is always 180 or something, hip-hop is usually 125, and so on. There are strong correlations between tempo and genre, so I totally disregarded those here. And I think that's pretty much it. That's pretty much it, yeah. Well, thank you.